This is an unlikely story about what humpback whales in Southeast Alaska and graduate students have in common. They both love an easy meal. While graduate students get their free food from the department office, whales have found an easy meal in Alaska's salmon hatcheries. I study how humpback whales are competing with Alaskan fishermen for Pacific salmon. Hatcheries are artificial nurseries for salmon. In Alaska, hatcheries exist to increase the number of salmon that fishermen can catch without overfishing wild stocks. Wild salmon spend the first part of their lives in streams where competition is fierce and many don't make it. Hatcheries make sure enough salmon make it through this crucial life stage. Then, when the salmon are ready, hatcheries release them to fend for themselves in the wild Pacific. These salmon will return to spawn and be caught by fishermen. Unfortunately, humans aren't the only ones who love salmon. Humpback whales have discovered that during hatchery releases, millions of fish fill the water, setting the table for an all-you-can-eat buffet. I'm betting that whales, like graduate students, will choose to feed wherever they can get the most food for the least amount of effort. We need to understand how different kinds of prey patches affect how much energy a whale spends while feeding and how much they get back in return. If hatcheries can make whales work a little harder for their meals, whales will leave hatchery salmon alone and feed on krill and herring in the wild. But how do we know how hard a whale is working to capture its prey? To do this, we attach these small tags with suction cups onto the backs of our whales. These tags record the underwater movements of these massive predators. This animation uses information from a whale we actually tagged to recreate her underwater movement. Using basic physics, we can calculate how much energy our whale expended as she dove from the surface, glided to the prey depth, and started lunging at her prey. While the tags are recording what the whale is doing, we followed behind in our boat and used a kind of sonar that told us what the prey patch looked like underwater. With this information, we can calculate how efficiently our whale was feeding. By tagging a bunch of whales feeding on many kinds of prey, we can model how differences between prey patches affect efficiency. Then, using this model, we can suggest smarter release strategies for hatcheries. But our recommendations won't be useful if they cost too much for the hatcheries to put into place. So we will use economic models to help managers choose the best solution. Each of those fish that ends up in the hands of a sport, commercial, or subsistence fisherman represents food and economic security for coastal Alaskans. Alaskans that support their families through sustainable fisheries are invested in maintaining the wildness and beauty of Alaska with a healthy and productive ocean for all marine life. And that's something humans, whales, and salmon can all agree on.